Hello, we are going to start the last presentation of the second gvSIG festival. It will be about geostatistics integration of R in gvSIG by Oscar Martinez from the gvSIG Association. So, Oscar, whenever you want.
Okay. I'm Oscar Martinez, and I'm going to make a small presentation about geostatistics and furthermore the integration of R in gvSIG. First of all, I'm going to make a small presentation, a small introduction to R, because some people in this field doesn't know this language. So, what is R? R is an open source programming language and a full software environment for statistical computing and graphics. It's a programming language, so we can create a lot of functions and a lot of libraries that are already inside R. It's widely used in multiple fields, from economy to biogenetic, and more important to us, in geostatistics. R is multi-platform, so it can be used in Linux, Windows, and Mac. You can find a lot of more information about R in its website, R project. What we can do with R? First, we can connect and we can use a lot of data resources, like databases from Postgres to Postgres, or just CSV files, or more GIS formats like shapefiles or rasters. Also, R is very useful to create graphs and work with time series, and create a lot of a small difference between the graphs. For example, you can see here on the left, this is a MDT, elevation model, and on the side you can see the mean of the height in this line of the graph. So this graph can be useful for a certain type of works, and it is not usually seen in GIS software. Also, we have 3D representations and a lot of more functions that you can explore in a lot of blogs or resources that you can find online. For example, in this link, you can find an important repository of R applied to GIS. R has a lot of packages. These packages are for almost everything. We can, when we open R, we can install any packages directly using the function install packages. So these functions connect online to a repository, so we can easily download new libraries for our workflow. These packages are almost added every day. Currently, this Grand repository has over 10,000 available packages, and as you can see, every day it has more packages. This is just the list from today, so as you can see, there is a lot of libraries ready to use. To develop scripts in R, there are two main tools. One is the R term, the terminal of R. this tool is included with every installation of R, and it's more simple. It's just a terminal, as you can see on the right, but very powerful. Also, there is an full environment that is RStudio. It's free to use for certain types of work, and I really recommend you to explore this tool because it's really powerful. It helps you to manage the version of libraries that you can use in your scripts, and it makes very easy to see the plots or the graphs, and it's very easy to debug and develop your scripts. Now I'm going to talk about the integration of R in gvSIG. We have multiple options for these integrations. All of them are around the scripting module. And the main objective is to extend the gvSIG possibilities. So we just don't have the Java libraries or the Python libraries that we can use in scripting. So now with this extension, the R plugin, we can create new processes that use functions from R, including all the libraries that are already in R, as I showed you in the current repository. This can be full geoprocesses just programmed in R, or these calls to R can be just a small part of our tools. Thanks to R, we can generate new type of graphs or reports that are not now in gvSIG or in Java, for example. One of these integrations is ranging. Ranging has really good pros, but a very bad cons. That said, ranging is implementation of R in Java. It's fully integrated with gvSIG because it's programmed in Java, so they work very well together. The main objective of ranging is to work when we are programming. Is to work directly with Java objects. This in the future could make very easy to develop tools, because like in scripting we work with Jython, and Jython is implementation of Python in Java. This is very good because we import directly Java libraries into our script programmed in Python. The bad cons of this ranging integration is their packages are very limited, because they have to rewrite all the libraries into Java, into full R, and right now they are just a few, or they have a little bit. There is still some work to do. Also, we found some bugs, so it's not fully functional. But some libraries that with some libraries it's already functional. But right now it's in development, and we hope the best for this integration, because in the future could be the one that we could use, but still will need time. This is the other integration. We call it internal R. This internal R means we created a new plugin that contains already an R installation. So with, for example, with the gvSIG portable, the version portable, it already contains an R installation on it. So we just can use it directly without making anything extra. What is good about this? It's compatible with all our libraries because it's a real, it's a genuine R installation. It's a normal R installation, like the ones you are using it. And it's as I said, it's a part of a plugin, so it comes with the installation of gvSIG. Some cons of this integration, it's not like ranging because it's R is programmed in C. So the way we pass parameters between Python and R, it's mainly text or path or similar. We can work with objects like or libraries like in ranging. Also, it makes more difficult, more complicated to boil a tool because usually the recommendation is to develop the tool in an external tool like RStudio, and later copy and paste this code inside the gvSIG tool that we have that we are creating. Other con is usually it's not fully updated because when we launch the gvSIG version, we put inside the last R version. So, for example, right now I think R is working with a new version, the 3.4, I think. But it's not a problem because we can't manually update the installation of R inside gvSIG. Another integration that it's very promising is the external R integration. It's a little bit different from the internal R. It's more compatible. The process is more compatible with all libraries because if we are using an external tool like RStudio that connects with our installation of R in the system, with this integration we will launch the same R installation. So we will be working with the installation that we will make in our system and downloaded from the R project website. It will be easy to develop because if we create this tool in RStudio and we check that everything is working, when we copy and paste this tool into gvSIG, we will be sure that this tool is working because we will be using the same R installation. Some cons is the limited integration because when if we want to send this tool to an external, to a client or to another user, this user will not have or installation of R. So the versions could be different from the client, and the versions of the libraries could be also different. So it can create it could have some problems with that. Also, it's an external installation, so we need, for example, in institutions, we will need a special tool to install this application because maybe we are not allowed to install other programs in our computer. This is not happening with the internal R because it will come with gvSIG. So with all of these cons, it's hard to pack. It's hard to pack in a tool. But if we are going to use just this tool in our computer, it could be easy to do it in this way. The execution of these integrations, it's of the execution of these scripts in R, it's very easy. So as you can see here, just in a few lines, we can create an R engine, and we can set the workspace, and we can launch a script that we have here, for example, and later we can call individually the functions of this script. As you can see, just in a few lines, we are launching our code. This R code, it will be in another different file that we will add here as a source. I'm going to show you in a few minutes a small video about this execution, and you will see how easy it is to develop a tool with this. One more thing, here, as you can see, you can, in the scripting composer, if you want to know more about the scripting composer, we have other webinars about this tool. That is the mainly developer tool right now for gvSIG. It's totally integrated, and it's also inside our gvSIG application. As you can see here, we are opening a script with extension of R. And if we launch this script directly with this button, or with F5, the functional 5 button, we will be using ranging directly. If we use this method that I explained, we will be using the internal R. We have some documentation right now. It's in Spanish, but I hope in the future, in a few weeks, or the next week, it will be in English. We have a workshop with all of this, and it's just step by step. So even if it's in Spanish, you can translate it with Google Translator. It will show you how to work with this module. So right now I'm going to show you this video quickly. As you can see here, we just have, I'm going to speed up sometimes. So we have here just one in gvSIG, one layer opened in a view. So as you can see, we have some fields. So right now we are going to create a tool to work with these columns inside our shape files. Right now we just creating the structure of the tool. It's just one main folder. Inside that folder, we create a data folder. This data folder will contain the R code, and as you can see here, we already created one script in Python that will launch this R script. So with this, we are just going to launch this R code. We developed the rlib library. You can import it directly in the scripting composer. Right now, with this function get layer, we are accessing to the layer that we have opened in the view. We are going to launch an engine of R that will help. It will make the work for launch these scripts. The function console that you can see above, it's just for show the output of the R programming language in our console. As you can see, we are using this engine that we call it R, and we are using one function that is called getPathName. This getPathName will get the path of the layer, so we can use this path inside of R code. As you can see here, we are just setting the work directory using the function getResource. This function takes the initial path where the script is being executed, and it adds another folder to this path. Here, as you can see, with r.source, we are calling this R script that we will see now. And thanks to this, we will be able to launch these R functions that we are going to create. So you can see here, when we already has opened an R script, we can call functions that are inside this script. As you can see, we are creating a regression model that will take two parameters: the path of the layer and an export name for the plot. As you can see, just another line is the r.end. So with this, we will end the engine of R. Right now, we are creating this function developed in R. Here, as you can see, wait a moment. In this label system, you can go to the extension of R app main plugin, and here in R cell, if you execute this R cell, you will open a terminal of R, the terminal that we are using in gvSIG. As you can see, we open it. So in this terminal, we can check if we have some library installed, and if not, we can directly install it with install packages. So we check it that we already have installed all these libraries that we are going to use. So right now we are just going to develop this script. We are loading the shapefile through the path of this layer, and we are going to create a regression model from two columns of this shapefile. So you can see, we are going to export this. We are going to export this plot in a PNG, and we are just creating a plot from these two variables that are paulatinal variables. Here we are creating the regression model, and we are adding this regression. It's a linear regression model. So we save the script, and we execute. As you can see here, wait. As you can see, we save the R script, and later we come here to the script one that this is the script in Python, in Jython, and here we execute our script. As we can see down, we see the output of the R terminal, and we can see that we recorded the plot in a PNG file. So right now, it's good because usually in our field, sometimes we forget about working directly with the numbers and not just with the geometries. So we can check. It's important for check if some values are not in the are not correct, or there are some errors on them. Here we are creating a predict model. As we can see, we using this regression linear model, we will uh, find these new variables. So for 79, this model, it says that the other field will be 11, and go on. And that's all. I let here this the developers list, main list, so you can write here directly if you have any doubt about this webinar. Also, you can write to me directly. We will. I hope we will update this documentation about R in English, and we will post it in the blog of gvSIG in a few days. So thank you for everything, and Mario, if you want to say something.
Thank you very much, Oscar. It has been an interesting presentation. There hasn't been any question until now. We are going to wait some seconds. But if you, I want to say that the presentation will be available in the YouTube and in the gvSIG YouTube channel, so you can watch the video later. So if you have any doubt when you watch the video, you can write an email to Oscar or to the mailing lists. Here you have in this last slide, you have the link and the address. So it seems that there isn't any question now. Thank you very much, Oscar, and thank you to all the participants. And we will see you at the next gvSIG festival. Thank you very much.
Thank you all.